Okay, sure. So let's start. Today we'll discuss about design of Instagram, system design of Instagram. I will again follow the same solution template, which I have prepared earlier. I've shared with you. So you should understand each and every word of this template. How do you approach a system design interview, right? This will be useful for any person up to director level to answer any system design question, right? So assume let's do a role play today. Let's do this group exercise where we will be designing an app like Instagram, right? Okay, so let me share my presentation. Today I have a presentation also. So I will share it briefly. Just give me a minute. Okay, so let me share my presentation. Let's see. Yes. Yes, it's loading. So today we'll be working on designing an app like Instagram, right? So, right. So now coming to basically the steps. In brief, I have the steps, right? So this is the architecture. So system architecture, then what you have to cover actually. You have to cover, these are the deliverables. You can think of, this is not the exact process. Process will start from very beginning. I'll discuss that in a moment, but this is about what is high level design. So high level design is the overall system architecture that includes major components and their interactions and dependencies, right? This one. So this is what first part in, these are the deliverables which you have to give in system design, right? So this one, this is what I was talking about, system architecture. So basically overall structure of the system, this is what you have to give. See, interviewer will just say that design an app like Instagram, right? That's all. This is one line question. Now ball is in your court. You have to drive the discussion. But yes, always have the result in mind that these are the things which you have to deliver. So first thing is system architecture, this part, right? So you need to create major components here, not all the components, but the major components, include the interactions and dependencies, right? How these components are interacting. Dependencies generally we ignore, because I'll just say remove this part, dependency. Basically better word would be interactions, right? Dependencies are design time dependencies, but we don't worry about design time. Probably you have to give runtime architecture, right? You should understand also difference between design time and runtime architecture. So high level design could be runtime and it could be design time. Can anyone explain what's the difference between design time and runtime architecture? Anyone would like to take an attempt? Ranjana, how about you? You understand what is design time and what is runtime architecture? Will it be same or it can be different?
It should be different.
Right? Yes, absolutely. See, design time is at compile time, how the components will be. Runtime architecture is when application is executing, how the components will interact with each other.
Interacting. Yes.
Yes, yes. So, so yes, we talk about dependencies. So if I remove this part, this mostly on design time, but what we will be worrying about is interactions. That means it is a runtime architecture. Awesome. Great. Then some approach, right? Probably you can design module because an interviewer may ask you to focus on one particular module. So be ready for doing this module decomposition, right? So you have to divide the system into smaller modules, subsystems, and then you can provide set of functions and set of functionalities. This is basically, you will be decomposing the architecture into various modules, and these modules will be set of functions which this application will be providing. See, now third thing is interface design, right? Now, nothing to do with user interface. This is interface for maybe web services, various calls, various remote calls. So different modules and subsystems, how they will communicate, the data format of communication, protocol and communication methods that are used, right? Okay, so let me choose another color. Right, so interface design takes care of data format, protocols, and communication methods, right? These clarity you have to give. Now, next thing is data modeling, database schema. We discussed this in depth. And then other consideration, which is system security, performance considerations, right? So this is about various deliverables which you have to give during interview, right? Basically, you have to focus on performance consideration. We can just remove this part, security considerations. You just need to know at high level the security considerations. But yes, performance consideration is more important here because unless you are applying for security expert position, you will not be going in depth with security, right? So I'm just cutting down this part. So what is important for you is performance requirement of the system, and you have to provide appropriate measures to address them. Even better, instead of this performance, what I would say, we will be looking into various non-functional requirements, right? So this is what is more important, right? So treat it performance as non-functional requirements. Correct? And this part is very clear. This is all about database schema, storage, etc. Right? Great. So let me come back here to, yes, so just I'm listing out again, same thing, but in bullet points, the component diagram, right? The APIs, the database tables, and non-functional requirements, right? So this is what you have to do. So yes, system design means the system is different components and you have to give the approach. Design is probably you are assembling different components, and this is you do by giving the approach, right? Correct. So yes, no, this is sometimes no, you have to use also incremental design, because here you may be given any existing system and you may have to enhance any system. So in that case, you have to bridge the gap between desired systems and existing systems. But yes, always think divide and conquer. Try to divide the problem into small problems, sub problems, and then you have to model the new system as set of subsystems. So these are all about conceptual things, right? So yes, these are, I'll share these slides for your reference later, but yes, you can look into this at higher level, right? So I'll take a pause for a minute so that you can familiarize yourself with this template. Please have a look, and any questions on this template, because this is what we will be following. So I just gave you a slight introduction, but yes, now I'll be going through in detail about the design process, and we will be designing Instagram. Okay. So remember the important parts. I will ask you to actively participate. Now, first is the functional requirement, right? Second is non-functional requirement. Third step would be, we will be doing capacity estimation, back of the envelope calculation. And then we will make some decisions based on the capacity estimation. We will come up with a high level architecture. We'll focus on few use cases. We will also do REST API. We will also do database design, and we will take care. We will showcase at the end that how we will be dealing with non-functional requirements and functional requirements, which could be around various functionalities, which could be around monitoring, observability, load balancing, various other stuff, right? So how many message application servers will be using, how many message servers will be using, caching, etc. Caching, when you say, we have to give two things. One is the caching strategies, other one is eviction policies, right? And then we will also throw some light on that, what kind of database to use, authentication method, and then probably you will share the high level design, and you will identify the bottlenecks, discuss trade-offs, and how we can resolve the bottlenecks. So this is something which we can do, maybe an incremental design. We may get a first draft of our design, and then very good, as a good architecture, as a good architect, we will refine our architecture, identify some bottlenecks and remove them, and come up with even a better architecture. People who have attended the Paytm payment gateway, design of payment gateway like Paytm app or UPI app, we already did this entire flow. We incrementally designed the architecture, and we identified bottlenecks, and we resolved them first by putting caching, then also providing redundancy at the database level, adding a message queue, etc. We took various incremental steps. Right. So finally, also leave some time for selling your design, or that means you have to convince the interviewer that your design is good, because this is most important part. You may be a good architect, but if the interviewer is not convinced about your design, then you may not get good feedback in the interview, right? This also happens to many architects in real world also. Many architects, they are brilliant, but their design never gets implemented because they are not able to convince people, right? So if you are an architect, you are very highly skilled, but you are not able to convince the developers that this design is good, then definitely no, all the effort which you are putting up will not give you the desired results because developers will not understand it. So as an architect, is very important that you should be able to sell your design. You should be able to make others understand your design, and they should also appreciate, and they should be convinced that this architecture is appropriate and correct. Right? Then they will get implemented, right? So that means how will you sell your design? You have to highlight that it's a distributed system. It has low latency because of cache, CDN, etc. It has scalability, both vertical and horizontal scalability. Wherever possible, you can do pre-processing, right? You can do load balancing. You should use partitions or sharding if you have to improve the performance. If you can reduce the network latency by using some techniques like geo load balancing. That means you are assigning the servers, or you are redirecting the request to the servers which are closely located to the client, right? And decoupling is very important. We saw last class in Kafka and message queue, the main reason why they do decoupling or separation of concerns is to provide you flexibility, right? So definitely you have to use microservices architecture. Only in few cases you will use monolith architecture where performance is very critical, super critical. But yes, most of the time you should be using microservices architecture. And you have to share that yes, your design is reliable. It do not have SPOF, single point of failures. You have reliability by having redundancy. You are using master slave architecture, availability zones, etc. All the cloud concepts you should be aware of, and you should be talking about what kind of consistency you have in the data. Is it the consistency as in the asset properties, or you have eventual consistency, right? Also, you should take care of administration of the application, also including monitoring, logging, tracing, so that you can also troubleshoot problems. And your application should be fault tolerant. In case of fault, it should be able to recover quickly, and it should be extensible. Extensible is maintainable, but yes, you can implement new requirements. This is what is meant by extensibility. So this is all about the solution template. These are the principles you'll apply in any design. Okay, so now today's question is design Instagram. So
in an interview, we have to discuss everything.
In 1 hour, yes, you have to discuss so many things. Speed is very important. Practice is very important. Yes, you have to discuss everything.
Oh, okay.
Challenging, right?
Yeah.
Correct. Yes. So if you have so many points, how many points I have? We have almost like 8, and right within each
Yeah.
of the points, I have 3 or 4 sub points, right?
Sub points.
Elaborating
Yes.
a lot of things because for your ease, but yes, you have to think whatever is applicable, right? Not everything will be applicable, but 60 to 70% of points will be applicable. So there are 8 different steps. You can think 2 or 3 different sub steps in that, right? Will always be applicable. So you will be almost discussing around 20 things in 1 hour interview, right? So
Yeah.
3 minutes, or you have to work on speed, right? So we'll be
Okay.
doing that, right? We will time also ourselves, uh, and then see how we do.
Mhm.
So so yes, let me come back to my slides, right? And we'll do this in the slide itself, some rough work, etc. Right? So this we covered, we discovered, right? Incremental design. So now let's say I have asked this question, design Instagram, right? Now, what do you mean by Instagram, or what are the functional requirements you understand from Instagram? Right?
We should be able to see
Yeah.
our friends' feed.
Yes, absolutely. Right? So in Instagram, so first thing is your feeds, right? Feeds are for posts, right? So you should see, you should be following in Instagram, you follow. So uh, people following. So it should show posts of your what you call people
Of
follow, right? People or
Mhm.
friends or celebrities you follow, right? This is your first important requirements, right? Great.
Mhm.
What else?
Our story, my story, something will be there, right?
Yeah, so first thing is you should be able to create, yeah, before that, even before you do it, you should be able to register, create your account, right? So you should be able to sign in, sign up, and sign in, right? Log in, right? Maintain your profile by updating your pic and details, email ID, etc. Right? Profile management. Then you should see the messages. And then finally, what else?
Followers, how many people we are following.
Right? So yeah, absolutely. So you are seeing the post of the followers, right? That is anyway covered,
Add post or add feed.
right? Okay, you should be able to add posts, right? Add posts. Okay, what do you mean by add feeds? Uh, you can add posts, right? You can add
Yeah,
posts. It
yeah.
could be picture. So post is what actually? Your picture or video.
Picture.
You can share video, you can share photo, and you can add tags, right? And add descriptions, text descriptions, right?
And location.
Right, location, tagging, etc. You can do, right? So yeah, you can add song, etc. and all that, but that is more on the front end side. That has nothing to do with the system design. That does not have much to do with system design, like you are adding songs or you are adding some filters, effects, etc. That can be done by doing some video processing or picture editing in the app, right? That is there. But yes, these are key functionalities. I would suggest one more, which could be, which is you should be able to, let me put here down, should be able to like, you should be able to share
Oh.
posts, right? These are various things which you can do, like share posts, like share other posts, right? So that's what I'm here. Cool. Good. So yeah, let's focus on this. There may be many other features also, like you can send some personal messages, etc. But yeah, direct messages and all, we can just ignore them. But overall, this is what your your functional requirements are. Let's talk about non-functional requirements. What do we need, right, in non-functional requirements?
We know Instagram will be used by a lot of many people, right? Millions all over the globe.
Yes.
We should make it scalable.
Okay. Okay. Perfect. Right. So in the non-functional requirements, let's do some add non-functional requirements. Right. So definitely it should be scalable. Yes, to hundreds of millions of users. Right. Yeah, or it should support hundreds of millions of, maybe let's say 500 million, right? 500 million users. Correct. This is one requirement. This is about scalability.
Is this this is audibility, right?
This is repeat, please repeat.
Availability, right? This is all.
Availability is how much it should be available. Is it fine if it is down one entire day? Right. Availability is about how much percentage it is available. This is scalability. That means these many users can support, but yes, concurrent user is something. Maybe, yeah, now user is, I register, but I never visit. Then am I counted, right? That is another question. I might have profile, but I'm not using and not an active user. Or I am always on Instagram every 10 minutes. That's another kind of user, right? So when we deal with users in large scale application, we count active monthly user, right? Because for many applications, many people create accounts, but then they never come back, right? So it's very important that you come back. So you use the term like active monthly user, or you can say active daily user, or active weekly user, or daily user, right? But yes, I would say we need to support definitely 500 million, maybe daily active users, right? So everyone is posting. Yeah. So
Next.
this is one important thing. So this is about scalability. Now, availability is always in terms of percentage. If I say 99% available, right? My application is 99% available. That means in 365 days, which are in a year, it will be down 3.65 days, right? Is it good? Is it fine if we have that availability? No, Instagram is definitely not down 3 or more days in a year, correct? What if I say we have 99.9 hours of availability? That means 0.365 day, right? Or is equivalent to almost 8 hours. It is down 8 hours in a year, right?
That's good. Yeah.
Good. See, let's ask Mark Zuckerberg. Okay, what do you think? What would be the problem if it is down?
Actually, I'm not so sure. Recently, few days back, Outlook was crashed, right? All over the globe for a few hours, 2 to 3 hours.
Yeah, right. See this. Do we have ads in Instagram? Right, you have ads, right? In Facebook also you have ads. They are generating a lot of revenue for every second, right, of viewerships. If it is down, it will be losing hundreds of millions of money. All over the world, they are showing ads. So even 99.9 is not good, right? What they look for, what all the good app looks for is this much availability, 99.999. Correct? Now, what does it mean? 99.999. So if I say 4 nines, this means 0.04 part of day, right? How much it will come? If it is like 8 hours is 500 minutes, right? So this is around
1 hour.
50 minutes, 1 hour, almost like 1 hour, right? This is almost like 1 hour. And 99.999. This is about 5 or 6 minutes, right? Basically, this is a rough calculation which we did, right? So clear, this is what availability is we look for, almost like, right, 5 nines. Right, so we did this approximate calculation, but I'm giving you the exact number. So yeah, I'll just give you, there is a chart about availability. Let me just share that quickly, which will give you how is the availability, right? Okay, just a minute. Right. Yes, so see, this is the, so that means if you have 999 as availability, right? So this means yearly 5 minutes, 30 seconds. This will be very close, right? Of downtime, which is yearly, right? Daily, that means you can be down by less than a second. Weekly, 6 seconds. Monthly, 26 seconds. Quarterly, 1 minute, 18 seconds. Or yearly, 5 minutes, 13 seconds. Because this is the expectation what you have in FANG companies that your software should be able to meet. Correct? So yes, maybe post this link to the chat window so that you guys also have this. And here in this is a good thing. You can also check, right? What if I make this, change it and make it 4 nines, what does it mean? It means 52 minutes, almost like 1 hour per year, right? Daily 8 seconds. And if you are talking about 99, that is 3 days, 14 minutes, 14 hours down, which is, right, which is no app would want to be like that because they'll lose a lot of business, right? Even Swiggy, Zomato, Paytm, everyone will aim for at least 99.9, 5 nines, right? That means this much time, availability, uptime, right? This is uptime, correct? So this is availability. What else? What could be other functional, non-functional requirements?
Low latency.
Latency should be low.
Latency. Yeah.
What do you mean by latency?
Responsive time.
Performance, right? Response.
Yeah.
It should load fast. So you should see see without having to wait. You should be able to see hundreds of posts in the client, right? So that's correct. So basically, latency could be high. Again, I'll give you some difference between latency. Say latency is a little bit of latency is fine. I'll tell you what is exactly latency, what is performance or response time. When I talk about response time, you understand that when I go to or when I click on any friend page, I should see it loading in maybe in 0.5 seconds. Right? So this is my requirement, is the delay, or all page should load within 0.5 seconds. Right? Sounds good? Right? 1 second, 2 second will be little bit bad experience. This is almost like near real-time experience, right? You see like everything is loaded and running locally, no buffering, everything, it happens, right? Even if your connection is not that great, in that also you get very good performance. Pages load very fast, quickly, and you see everything without seeing any buffering. Right? So this is one requirement. Latency. Now let me tell you, what do you mean by latency? Assume you are following me. I upload one picture, okay? Will you see that instantly? Or can there be delay? Maybe 1 minute delay. I upload now, you see it. I have hundreds and thousands of, maybe I have say 10,000 followers, right? Realistic. So yeah, I'm not a celebrity. If I'm a celebrity, then I may have millions of followers, right? But yes, in normal case, possible that someone has few thousands of followers. So if that person uploads, each of the follower, if he sees the image after 1 minute, is it fine? Right? No problem, correct? So this is the latency. I'm uploading something. You are seeing it, not exactly real time, but maybe 1 minute later. Yeah. Right? Because, but yes, maybe even lesser you would like to do, but your latency will be lesser than this. In Twitter, you get even less latency because people use it for news, and sometimes news, yeah, you should get less than minute of latency, right? So should be definitely low latency. But yes, what do you feel? 1 minute, let's take it. 1 minute is good, right? Because some latency is better, because that means that much time you can cache some information. Yes. Any other non-functional requirement? Good. We are good. So we discussed non-functional requirements. And definitely no other non-functional requirements will also be there, that if I upload my photo, the photo should be available forever. Right now they have introduced some feature where my post disappears. If suppose the reels are there, then it goes away automatically by after 24 hours. But yes, mostly if I upload some pictures, post, it should be available forever. So this is about reliability, right? If I upload a photo, the photo should be there forever, right? I should not lose that photograph. Clear? So this is non-functional requirement. If you can discuss this, then this shows you are an experienced architect. Shall we move on? Yeah, we'll move to next part. We discussed functional, non-functional requirements. Now, based on these inputs, let's do back of the envelope calculation. So that's the next part, right? Which we have to cover. Let me choose some other color. So this is about back of the envelope estimation. Yes, this part is what we will be doing next. Okay. So just a minute, give me. So let's talk about what data to store, right? What would be the data schema? Because some understanding of database is required to do how much, because what will we try to do? First thing is, let's see how much storage do we need, right? Right. So how much storage should we have on our servers? How can you estimate this? Right? Because we got the non-functional requirements. So for this, let me switch to a document here. Let me get a doc. So Google Doc is better for back of envelope calculation. And this is important step because as an architect, you should be able to do back of the envelope calculation. Right? Just a minute, my Google Doc is loading. I need to create a new document and then share it. Am I connected?
Oh, yes, sir. You are audible.
Right, because yes, somehow Google Docs finally loaded. Yes. Awesome. Maybe sometimes Chrome is not that good. So I just remove this part. Let me clear this or this, because you will be remembering, right? All these stuff. Yeah. Availability, we want 5 nines, 500 million users. Performance of each and every page 0.5 seconds. Latency maybe one minute. And reliability of photo, that if I upload a photo, it should be available for, say, next 20 years or 10 years, right? Something like that we can have. Yes. Now, let me clear this, right? And then do back of envelope calculation. So let's calculate what kind of database storage should we use, right? So definitely now I don't need this part annotation. I can write here, right? So we said we have 500 million users, right? Active users and daily active users, right? So let's say this is your number. So, right. And then let's assume that they are uploading, maybe many people are uploading 4 or 5 photos a day. But yes, let's say every user is uploading 1 photo per day, right? So that means we are getting around 500 million photos per day. Sounds reasonable, realistic? Correct?
Yes.
Yes. Because yes, these many photos you will be getting. So what should be the size of one photo? Let's say 1 MB or 10 MB. What would you like to keep the size of photo?
For calculation purpose, 1 MB.
Right? Generally, it will be
Yeah.
less than 2 MB, 3 MB would be there.
Yes.
But yes, definitely what we can do always when someone is uploading high resolution photo, we can do some compression and keep some 1 MB photograph. Right? Definitely people will be uploading videos, which could be several MBs also, and they will be uploading high resolution. Some people will be just uploading minis or GIFs, not that high resolution images. So maybe few KBs of information they will upload. But yes, on average, I would say one photo. Just this is an assumption. This will just give you. So you get 500 million photos. So this is into 1 MB, right? So anyone has knows how much is 500 million into 1 MB, right?
500 terabytes maybe.
500 terabytes, right? Absolutely, right? Because 500 million MB, 500 million MB means 500 in 10 to power. So yes, absolutely right. This is terabytes. Terabytes, TBs of information per day, right? So basically storage, when you calculate for monthly subscription, right? Because all these storages are available on monthly subscription. So into 30 will be the so that will come to around 1500 terabytes per month. Correct? Right? Or you
Yes.
can say 1.5 petabyte. This is the storage you need. And if I say that our image should be stored for next 10 years, so 12 1.5 into 12 months into 10 years, this is coming to be
30.
somewhere around 180 petabytes of storage I need, right? Clear? Right. So overall, this much memory I should be having.
So this is only for photos, correct?
This is only for photos, right? Yeah. How much will the profile pic take? Profile pic, your age, your location, your hobbies, etc. Other profile details. How much will it take?
Definitely the
Net,
profile size will be very less, right?
right, 1 KB.
File.
Let's say 1
Yeah.
KB. Yeah, you have around maybe okay. Let's say 10 KB because maybe you will have say 1,000 words of description. Yeah, like whoever is your favorite actor, hobbies, location, whatever background, etc. All these description. I'm feeling high today or whatever you will write 1,000 words. So 1 KB, maybe 5 KB is your image. Maybe yeah, you may have multiple images also profile pics. So let's say 10 KB is your data, right? For profile, for one user, you have 10 KB of data. Right? Now, if you have 500 million users, right? This is the data which you will need. How much is it? 500 into 10 KB. 500 million, sorry. We have these many. Right, we did that just before. We did 1 MB. This is 100 times lesser. Correct. So you have 5 terabytes.
500 terabyte.
Correct. KB is just you 5 and yeah. So you have terabytes, 5 terabytes. Because 1000 is gigabyte, and then you have 10. So you have again 1000. Well, means that is actually the way to calculate is very quick. Is like you divide by 1000 and make it gigabytes. So 5000 gigabytes equal to 5000 terabytes, right? And see, the profile picture is always one time, right? So you don't need this much storage per day. It is throughout lifetime, right? This is the storage which you require throughout. So this is 5 terabyte. 5 terabyte is less information. Maybe you need one hard disk is 1 gigabytes, right? So 5 terabyte is something which is manageable in few servers. Servers will have 5 terabyte of storage. You get hard disk of 5 terabytes, right? 5 terabyte SSD. SSD is what I prefer, right? So see, just for some fun, I can buy this hard drive, right? Seagate hard drive. This is a I can get the data, right? This is I'm having to spend less than 12,000 rupees. So not a big deal here for storing profiles information for 500 million users, right? But definitely you need backup. Maybe do 3 backups, right? 3 copies, right? So I can have 3 copies of this information. That means I might need 15 terabytes of overall storage, right? Backups should we have, right? And generally it is advisable to have 3 copies, because if 2 copy fails, then still you have 1 more copy, right? So this is guaranteed that you will never lose this information. Yeah, because if you have bad luck, both the hard disk crashes at the same time. That can also happen. But yes, you need to be definitely really having a bad luck if you want 3 copies to be failing at the same time. Right? So that should never that will never happen. You will always have time to replace one hard disk, right? And copy again, create another server. So this is good. But yes, you should also do backups here, at least 3 backups. But here it is expensive. But yes, you cannot go away with this. This maybe will come around petabytes of storage. 180 into 3, right? 180 is like 200 petabytes. So I may purchase 600 petabyte of storage for storing images. So this is good. This is good first thing, right? So this information, yeah. Go ahead.
We cannot store these many information in relational database table.
Yeah, see, these are photos. Photos you definitely no need to store in the relational database. You will need some storage which is like S3 storage, right?
Hmm.
Correct. So you will purchase 600 petabyte of S3 storage. How about this? This is something you will store in the database.
User information, you're saying?
Yeah, user information, right? Because this is your age, your location, your maybe profile pic. Profile pic you can optimize, still store it in S3, but URL you might have to store. So for user, what all you will store? So right. So in user, you will have a database, right? So you will have user ID, you'll have email, you will have name, right? You will have age and various other details, lot of other details, correct? So maybe
Last login.
15, 20 fields,
Mhm.
right? Yeah, last, when do you visited last, right? Last logged in, whatever, yeah. Or many things. They keep introducing new and new fields. Your favorite sports, your favorite, tomorrow they can say favorite political party or whatever. They can add many, many fields. So, but yes, it will always be manageable. It will never expand. Maybe 15 terabyte will become 20 or 25 terabyte as time passes, because they may have more and more features. But yes, still it is well within our range, right? So what should we use here? Which kind of database to use? You need to search fast. You need to maintain relationships. Yes.
If that is the case, then we should use SQL, like a relational database.
No, relationship, I mean, you need to have friends, right? I am A is friend of B, and there is a network of information, right? First level connection, second level connection.
Mhm.
Yes, you can use a relational database also. So for example, I may have a table. So a user table, this is my user table, correct? Then I can have another table, which could be follower table, right? So here I may have details about user ID and follower ID, right? Correct. That's
Mhm.
all. So a user may have what kind of relationship it is? Is it?
One too many.
Say user can have many followers. A followers, or maybe basically I should have called followee, right? And follower. This is basically user, right? A user can have many followers, and a follower can have only one followee. This is what you are saying. Correct? Is correct or wrong?
Can
What is
have
the
many,
kind of?
can have
What is-
many
Yes,
following.
yes, a follower may have many followee, and a user will have many people who can follow both sides, many to many, right? So this is many to many relationship, right? So you have to be careful in interviews. This is important, giving these kind of relationships. But yes, with these tables, you will be able to get this mapping because both are users. So this is, you may be able to put all this information here. Is there anything we also need to store? Are we missing any other entity from our requirements? Because our requirements was user profile management, updating photos, videos, updating posts, right? Generating news feed. So is everything there covered in the database? Is this storage is good? 600 TB of storage for this.
How about post? We are not
Yes,
discussing.
post, yes, you have to consider a database for post. Yeah, this is also done, right? Something like this. But how about posts? Right? So we'll have to design a table for post. How will you design a table for post? Correct, simple, right? In relational database, you can store. You may have post ID. You may have user ID of the person who creator ID. Basically, this is the creator, right? Maybe you have
Time.
an image URL. You are having an image also for the post. Yeah, go ahead. You are saying something.
Time will also will be there, right? Because after 24 hours, it should.
Okay, time.
Yeah.
Create time. Yeah, you may have some policy. Maybe user can mark that auto deletion, or for reels, it deletes, gets
Yes,
deleted,
stories.
right?
Yeah.
So location of the post, or yeah, and creation,
Description.
creation, date and time, right? And description, yes. I'll add this here, right?
Emojis.
Likes, right? Likes. Right. So yeah, this is maybe different kinds of likes are there. You may store, but yes, let's assume there is only thumbs up, thumbs down right now, which is likes, right? What else? Posts can have comments also, right?
And also the art symbol for every comment, right? Yeah.
Comment is done by users and it's on the post. This is foreign key, right? And then definitely the text of the comment and date time creation, date time of the comment is displayed in the UI. Right. So how much storage do we need for posts and comments? We know users are putting one photo, maybe one post, right? One post per day. Let's go with this same assumption. Yeah. See, again, we don't have to be a very exact because we are engineers, right? If you would have been product manager, then you have to do real research and figure out exact number, reasonable number. But yes, for system design purpose, we just need to get the range. So we can say that there are these many posts per day, right? A post has an image, can have an image also, and a lot of other details also. So shall we also say 1 MB per post? Yeah. People may type a long post also. 1,000 words, 2,000 words. You may limit it, right? But yes, they may put image also in that post. So let's keep 1 MB, right? Basically, a similar calculation is here, right? So maybe 1500 terabyte of your storage, because post also maybe you may delete it or maybe you keep it same, right? So yeah, basically this is post only, photo or post. Maybe they are same, so no need to worry about it. But what about the comments?
They are text.
Right. So yeah, so this is, I think this we can get away with, because photos or post we can just say in this itself. So very similar, right? But yes, for a photo, how much comments are you likely to get?
Maybe followers, total followers, maybe.
Yeah, depending on followers, but yes, you have to estimate on average, maybe few people are getting thousands of comments, few are not getting. For example, no, I am not getting much comments if I post my photograph, but yes, some people will get thousands of comments when they post their photograph, right? So let's say per post you get 10 comments. Yeah, you can always say, right? You have 500 million posts per day into 10 comments each, right? So 5 billion comments. See, comments are always text, right? Comments may also have like and all, but yes, that you can also use here, but like count, that's easy. 5 billion comments, but yeah, let's say every comment is 100 characters, right?
Arun,
Sometimes people are just saying, yes, go ahead.
what about nested comments?
Right. Yeah, we can deal with it, but yes, yeah, in that 10 comments, you will have nested and all that comments, all possibilities are there.
Yeah, I mean, like for the nested comments, how we are managing in doing data modeling for that.
Yes, let's come to that. Yes, but yes, let's finish this. Next, we will see how to store nested comments, right? Good. Perfect. So I'll give you a schema for nested comments also. Not very tricky. You would have figured out. No worries. But yes, let's see how much storage is required. One character is 1 byte, right? So 5 billion bytes. So one character is 1 byte. Also, no, 100 bytes, right? So basically, this comes to 500 billion bytes, right? $500 billion bytes is how much? 500 GB. Easy. Correct? In my laptop, I can store the entire comments per day, but it's per day. Right? So monthly, 15 terabytes, right? Because 500 into 30 per month. Yeah. So every day I need to buy a new laptop, right? So 500 GB is it. That's the hard disk of one laptop. But yes, 15 terabytes of storage per month, and for next 10 years, because if we just have to plan for next 10 years, again, terabytes. Why the same number we are approaching again? See here, this is not, yeah, this 15 terabytes and 180 terabytes, right? Yeah, but yeah, see here, it was petabytes, 180 petabytes here. And then when we had 3 copies, 600 petabytes, we said, here we have 180 terabytes for 10 years. Right, so lesser, 1000 times lesser, right? So if you, when you want 3 copies, you can keep maybe 500 terabytes, right? Or 600 terabytes, but yeah, you can compress it also. Maybe I don't bother to take the backup for comments, right? So this is the storage which is required for this. Next thing, yeah, let's come up to the nested comments. Now, what do we mean by nested comment? Say, let's say we have a photo here, and then someone commented that, right? Say comment 1, right? So let's say this is, someone says blah blah blah, right? Something like that. He said, right? Someone else comes and he replies to this sub comment, right? Something, right? And then there's another person comes. He also posted something like that at the maybe top level, or maybe again replying to the first comments all only, right? Something else he replied. Then another person started another comment. Like this is like nested comment, right? So here you have comment 2. Here you have comment 3, right? Something like this. And then you have comment 4. So you may have any number of nestings, because now someone can reply here and start fighting, right? So yes, you may have comment 5 here else. So how to store this in the database table, relational table? Is it possible to store it in the relational table?
Yes.
Parent comment ID.
Yeah, so you have already the table comment ID, yes?
Yeah, parent comment ID.
Okay, yes, absolutely. Nice. Parent ID, you can always put parent ID, because that's what you need, and you can display it in UI, right? If you can link, this is a way to link the parent and child relationship in comments.
Tarun, also like the parent comment ID
Yeah.
can be null. Instead of post ID, can we replace with like can we replace with some field where it can be post ID or parent comment ID, because both cannot be not non-null, right, at the same time.
Yes, yes, absolutely, absolutely. Right. See, post ID is different thing. Parent ID is different thing. Parent ID can be null, right? If the comment has no parent, then parent ID will be null. For example, for comment 1, it has a post ID because maybe this is for some post. The comment can be done only on post.
Yeah, but for the nested comment ID, it doesn't need to know post ID, right?
Yes, yes, right.
For
But
the nested comments,
no, you
uh,
need to know. You need to know because
because
the
the
same
if
comment
you know the
ID,
parent comment ID, that will already has the comment post ID.
right. Absolutely, absolutely. Yes, yes. Yeah, right. So that implementation detail you can take care. No problem. Right. So assume this is the post. Post ID is 456. This is my comment. Comment 1. This is comment 2, 3, 4, 5. Assume this is the IDs. So my table will be, let me insert a table so that you guys are clear about this. How many columns I need? I need maybe 6 columns, right? So comment ID, post ID, parent ID. Then this is the text and maybe date, right? So ID 1, post ID, post is 456, parent ID null, text empty, and date, some date. Right, something here is fine. Right, so I'm just trying to put time also. Right, so something like this. For other yeah, comment 2 is 2, post ID is still same, parent ID 1, some text. Yeah, okay, this was blah blah blah. So right, and this is whatever, right, something like this, and some time, right? Maybe. Great, is this fine? This is the database design. Sir, you can have a relational database for comments, and yeah, for this you can have a relational database. For posts also you can have relational database. Image you have to store externally in S3 or some cloud storage, and you can always put the URL in the post.
Tarun, in the comment table, once
Yes.
go down to that comment table, like
Yes.
yeah, here we have post ID, right? Like in that column,
Yes.
if we maintain the post ID or parent ID in one column, we can, like, we don't need to index the parent ID. Like when we are searching, it will be useful, right? So if we like, can we able to maintain one column for post ID and parent ID? Because if you know the parent ID, then we can know the post ID, and we can, if we maintain in one column, if it is indexed, it can be helpful in querying as well.
Yes, yes. Yeah, that all optimization you can do, but do not optimize unnecessary, right? Premature optimization we should avoid, right?
This will
Simplicity is
validate
important. Readability, maintainability is important. So let's give this clean architecture. If some performance problem, we can always optimize, right? That should be the approach. Right? Yes, definitely. No, this is a simple example. In real world, you would need optimizations, right? But yes.
So it's like we get the, we
Tell
will
me the columns. Yeah, let me talk about this. Give me your table structure, right? So let me introduce another table. How many columns you need?
all columns are same. It's just that post ID and parent ID are merged. That's it. Like in case of the second one, the it will be the one. But we do not know whether it is a comment ID or post ID. Then we have to maintain another enum, whether it is a comment or post. Again, it will boil down to same thing. So yeah,
Okay, okay. Yeah, got it. Got your suggestion. Perfect. Yeah. So instead of you just use one ID and you have a type, whether it is post or right, you can do various optimizations.
yeah.
No problem.
Firstly, I will query using the post ID. Then I will get all the comment IDs and I will query using that.
Yes.
Query using the
Yes.
same thing. So that way I will get the nested comments.
Yes. Right. Another optimization, which generally I prefer simple optimization. One optimization could be I can also put a level. Right.
Yeah.
So then I know easily where to put what comments, right? Rendering it becomes easier. Yes. So some optimize, yeah, you can do many optimizations, right? So in Twitter, they do optimization that they merge date and ID, right? So yes, so they will get the millisecond, right? So it's something time optimized ID. They use this. So anyone can think of what is the advantage of that, right? So what
How
they
we
What
do
is
can
the
is,
question? Right?
my question is in Twitter internally, right? Don't tell it that I know this to this guy, Elon Musk, right? So, but yes, they use this structure. They use a time optimized ID. So what they do is they generate ID like this.
yeah, it can we will able to fetch the data in the most
Correct, correct.
yeah
Yeah,
ascending order of the time or something like that.
right, right. So they generate an ID based on timestamp, what is their current timestamp, and then they generate a random number. And they concatenate both their string and they make it a ID, right? As a comment ID or tweet ID. Now, the advantage of this is they have the time information here, and in Twitter, everything is shorted as per time. Most recent things you see once, see at the top. Same you need in Instagram also. Most recent post, you should try to put it at the top, right? So you can use time optimized IDs, but all these optimization techniques could be done. You have to limit because we have to complete the entire system design in a given time. So we have to be careful where we have to dive into deep, where we should just discuss at top level. Interviewer is satisfied, go ahead with this, right? So now, what databases should we use?
For comments,
Yeah,
for
for
comment,
all the tables, all the tables.
SQL, because we have one table has relationship with other tables.
Yeah, for comments, what you can use? You can use MongoDB also, right? You can use SQL also. Yes. Comments, how many comments you have? See, you have so many comments, billions of comments.
No rights, right?
Yeah, write very frequently, large number of write and read and write. Prefer MongoDB. Right? Almost. So let's do that calculation also. See, 500 million posts per day and 10 comments per day. So that means 5 billion comments per day. So how much is per second?
3,600.
So divided by, yeah. So 24 hours into 3 is 1,600, right? Because 60 minutes and 60 seconds. This becomes 3,600, but into 24. So that means almost like this is, I showed you, no, 184600, something, some number like that. It will be, right? So let me just quickly get this. What is the value of this? 24 into 60 into 60. This is, yeah, 8. Oh, sorry, here 86400. But yes, I told you, you can always optimize it to 100K. Right? This is almost like 86,000 is 100,000. Right? So 100K per day. So I have to divide 5 billion by 100K. So maybe 5,000 million by 100K. I have to divide, right? So I can say 1,000 and 100 I remove. And so 5 million I divide into, right? Almost like
So this 86,400 is a chorus, right?
is seconds,
Second,
right? Seconds in a day.
okay.
Right? So you have to divide 5 billion divided by this number, right? So to get this, how many writes per second? Correct?
Yeah.
So this is coming to be around 50K writes per second. Right? Reads will be more. Maybe one comment will be read by 100 users or 10 users, right? So it could be 500K or more reads per second. This is high volume. May not be handled by relational database. Performance also you need. Consistency you don't need. Eventually consistency is fine. Latency you don't need high latency. No, sorry, low latency you don't need. High latency is okay. If I post a comment, yeah, generally real-time communication is preferred. But if you see after 1 minute, fine, okay. Right? In chat, you need it immediate. In comments, this fine. If 1 minute later you see, no problem, right? So let's use here MongoDB. Or you can create multiple shards per region.
Arun, if you use MongoDB, if you have to query, like we need to get all comments, like for let's say, and if we know if there is a use case where we need to join, it will be a problem, right?
No, is there a use case where you have to join? Right? See, in MongoDB, you will be able to get this because, okay. How to store this in MongoDB? Now we discussed how to store it in relational database. So see, one option is use MySQL, right? Relational database. That means relational database. Create 5 shards, at least 5 shards. You may go with 10 shards also, right? Keep creating more shards as the data is growing. That's what, right?
But if there is one use case where we have to join, we cannot store in MongoDB, right? Like let's say I want to, let's say someone deactivated their account,
Yeah,
and
but
we need to.
just a minute. Let me first finish this part.
Okay.
Relational database clear, right? We can create shards. Yes. Any questions about this?
Yeah, 10 shards means it is a 50K reads and writes, right?
Yes. So
50K
it will
reads.
get divided, right? It will
Yes.
get divided. So maybe 5K, 10 shards if you are having 5K writes per shard is possible per second. This is okay with relational database, no problem with that. Yes. But yes, you can use any database with sharding, and you can shard based on. Now, what should be the sharding strategies, right?
Post ID shard key.
Correct. Yeah, you can use that. Okay. Based on, you may use various approaches for sharding, because what you need is you don't need, see, comments. Yeah, perfect. So that would be good strategy, because if some comments for a post are in different shard, then you will be in trouble. But provided you have all the comments for a post in the same shard, this is good. So yes, I would suggest you can do range-based sharding, right? So I would say range-based sharding you can do. Say, for example, you can say 1 to 1 million, right? So, okay, 1 million post ID. Shard 1, right? 1 million to 2 million. Shard 2, right? So, correct? Like that, you can shard 2 million to 3 million. Shard 3, depending on post ID. Right? Something like this could be done. Yeah, or you may generate a hash of this post ID and then shard it, right? But there could be, these are the approaches which is suitable. Now, let's come to MongoDB. So here, clear? See, comments have to be loaded also fast, 1 minute performance. You may have to use caching also. So with caching, right? So we have to discuss caching. Caching could be based on least recently used first. All right. Or could be most frequently used comments. And cache the comments for faster UI performance. Client-side caching, server-side caching, database caching, all that you can use. Now let's come to MongoDB. How to store these in MongoDB? See, I'm covering the MongoDB part also, NoSQL part also, right? So all the basics of NoSQL, please remember, you can apply it in other system design questions also.
MongoDB per second, how many writes and read can be done?
Yes, MongoDB.
How
Okay.
many
Yeah,
writes are
yeah. MongoDB is horizontally scalable. Right. So I gave last time also. If you have relational table, right? So 5K writes per second is fine. Right. See, again, depends on how complex is the write query. But yes, in general, 20K reads per second. This is something can be handled by relational database. Right? For NoSQL database, all NoSQL databases are different. But yes, say MongoDB or some similar databases, there are many hundreds of NoSQL databases. Handling around 22K writes per second is fine. Reads could be up to 50K reads per second. Yeah, 50 to 100 also, because they are optimized for high reads. Right, so this is the number. Right, definitely you'll need multiple multiple servers in MongoDB also, but they can be clustered. Right. But yes, you should understand that MongoDB store information in the form of document, and which is JSON format, right? So you will have ID, which is the comment ID, user ID. You just convert this table into the right. So here basically level, and we missed one column, which will be user ID, right? So comment ID, you can have post ID. This for uniquely identifying. And then you have text. Right, so you can store like this. Basically, it's JSON, it's easy to convert, right? But yes, here you can also store replies inside. Right, for all the comments. Right, so basically you will use a JSON instead of a table, right? And other replies also. So basically, yeah, replies, basically you will have an array. If there are two replies, you will have here again another JSON, right? I should show this JSON in a well-formatted manner, right? So let me open a JSON editor so that you view it properly, and let me generate some sample comments and then show it. So I'm just typing some real JSON for the MongoDB so that you get, and I'm adding it in the JSON editor so that you guys get a good understanding of it. Right, so something like this will be the structure I'm just showing here. You see in the left side, and this is what your JSON, your ID, comment ID, then user ID, post ID, then you have some comment, then you may have a date, likes, replies, then again ID, comment ID, and one reply I called it. This is sub comment. Right, something like this will be your structure for JSON. Clear? Right, so this is a view of basically table view. Yeah, you can create nested structure. You may have many comments for in documents, right? So this is about how you will store the information in MongoDB. It will understand the schema and it will retrieve it fast, and you will get good performance and you will get good data volume also. So no problem with that. Yeah, go ahead.
Yeah. So like Instagram also shows like number of comments, overall total number of comments that all my posts got, right? So in order to get that, we need to do joins, right, with the number of posts.
You need to count the number of records, right?
We should also have the user ID in the comments, then it will be
Yes, absolutely. Yeah. Yes. So you can count actually how many comments are there per post by, you have the post ID field.
no for all, like overall for my account, all the comments combining all the posts.
Yeah, you
Co-
okay. You get that? If you have a specific requirement, you can implement it. Yes. So yeah, from users, you have the comment count for all the posts, and then you sum it up, right?
Yeah, for that, to get comment count of all the posts, uh, let's say I have posted like 1,000 posts. To get
Yes.
count, then we have to do joins.
Where joins? MongoDB don't require any joins.
Yeah, we cannot perform joins, but we need to do a for loop and we need to take every post and get the
So what join? We have only one document, right? We have one document which is for posts. Everything is available in posts, right? So you can get that. Right. So basically how you will get is, okay, MongoDB has some API kind of interface. You'll write, you maybe the client.connect, right? This what you connect to database client.db. You will give database name, Instagram DB, something like that, whatever is your database name. Then you will give comments collection. You'll try to retrieve collection, and then comments is the name of your document. Document is like table, right? So you'll get all the comments. You say comment count. You will say comments collection dot count documents. You may give the filtering criteria here that post ID, right, is post ID, right? something like this, you'll get the comment count for all the async, because this may take sorry, async, this is await, right? So this is your input, right? So something like that will be, you will get the post counts.
Or else we can also add the user ID as part of the table, and we can get all the comment number using that user ID.
Right, absolutely. Correct. So in low level design, we will discuss this further, how to retrieve, how to do that, all that. But yes, it's possible easily. Don't worry. Now let's move on to other table, profile table, user profile. How will you store?
It's 15 TB only, right? User profile.
Yeah, username, password also maybe we need to restore, right? So password will be stored secured. Yeah, here you have, here you have the user ID. So yeah, you may use password as well. Right, so password you can encrypt, encrypted password. Don't store the text password. Right. You may again use relational database with sharding, or you can use MongoDB as well. Right? User creation is not that high traffic transaction, but yes, you need fast performance, you need flexibility. You may go with NoSQL database, MongoDB, because you don't have to modify the schema. You can keep adding more and more fields, right? You don't need consistency. You again can have high latency. No low latency is required if I upload my photograph or change my marital state or whatever. Yes. Okay, I have to. Yes, anything if I change, then if it goes out after a while, few seconds, few minutes, no problem with that, right? Another kind of database you may also consider here is key value store, right? So Redis, right? So that can also store.
This for cache or database?
Yeah, Redis you can use as database also, right? So you may use it as cache also, or you may use it as database also. Correct. So just giving you a structure. Basically, you have a key value pair. So here key is your user ID and value will be your email, name, right? Bio or intro, whatever you call it, right? Profile, image, URL, right? Could be whatever. Whatever it could be. Right. So some I'm just putting some example. Yeah. Right. So something like, sorry, this is name, so this is email. So right, so something like this could be your Redis information stored in the database, right? See, if you need cache, you put TTL, which could be 1 minute, hour, day, time to live. All data in the Redis needs to have time to live. Right? Just see, this is important concept. This is for Redis. For this, yes, this could be indefinite as well. Right? So use this setting indefinite for user profile so that your profile is permanent. Otherwise, you will lose this information. Right? So just this is for information purpose only. This is the database design. Right, so we did this calculation. And basically the architecture could be now simple web application architecture. So you have a user will have a front end. Front end could be stored in some web server. You will have a request response, HTTP request response. Web server you may create in Python or Node.js or Java. It can read the images from S3, some distributed file storage. It can also read from the database. Right? So this is general architecture. Right? So right, you'll need load balancers because you have multiple servers. So you'll have load balancers. Web server for storing web pages, application server for storing backend logic, and then finally database servers. So this all things which we covered earlier. So let me come to the architecture. Yes, you have to now create microservices architecture based. So this is one of the recommended architecture for it because you have various use cases. So you create microservices, right? So for user profile management, have a user profile microservice. Right? So this is for user profile management, this part. So when you are creating a new user here, he'll make a request. This could be API gateway. I would suggest this one could have a API gateway. Right? Because yeah, that layer will route this request to user service. And user service, it is storing in any database. Could be, we also discussed here that we are storing this in Redis, right? So let me take this out, cut this out. Yeah. Okay, let me cut with the red. So here we will say that this is Redis. Right? They are using cache also here, right? So yeah, you may use MySQL as and then a cache, right? So you may use here. Don't have to go with detail of this implementation. Yes, you may use here cache, could be memcache or could be Redis cache also, or MongoDB and this. Friend service. Friend service is doing graph. Right. Now, what is this Kafka layer? What is it being used for? Can anyone tell?
Syncing database.
Pardon?
Syncing database in a cluster.
Which database you have to sync? This is your adding friends. Adding friends, your friend adding friends means maybe you have a follower table. In MongoDB, if you do, or in Redis you do, you may also add follower ID there. So you update the friend. Kafka is used for handling posts. Right? So that's not clear here, but yes, I'll try to make that clear. Let's see. Right, so basically, so yeah, here this is the microservice architecture. You may use different kinds of database also. So for example, Neo4j is a graph database. It is good for maintaining relationships. This can be used. This will result in you can get the list of friends very fast with Neo4j. Right? So that's something good for storing. They are using Cassandra for storing posts. Right? Cassandra can also store different kinds of data. It's a NoSQL database, right? But it is high performance database. For post comments, you can use Cassandra. Cassandra can also be used as a wide column database. Right. So this is generally, yeah, you may use exactly the relational design in Cassandra also. Right. Wide column. Anyone has an idea what is wide column database?
No, Tarun, I don't have any idea.
Thinking in OSQL, we can use SQL queries.
Hmm?
Yeah, actually,
NoSQL, what does it mean? What does it stands for? NoSQL.
recently I read somewhere in
No
NoSQL.
stands for not only SQL.
Yeah, correct.
So Cassandra is supporting SQL. Cassandra does support SQL. Its query language is very similar to SQL, but they do support advanced feature also. They call this query language CQL rather than SQL. They call it Cassandra query language, which is very similar to SQL. Right? But yes, it has some advanced features. So they do not support joins. They have primary keys. And there is setting. If you also need consistency, Cassandra also allows you to have consistency levels for read and write operations. You can control the data consistency. But yes, when you make it consistent, availability is compromised. CAP theorem is applied here in Cassandra. So you can choose either high availability configuration where consistency will not there, or you can choose high consistency configuration. But here you need to choose high availability configuration because consistency is less important. Important is availability, right? Now, what does consistency mean in this case of Instagram? I'll show you. This means if I am the user, I as a user, if I am, say, assume this is my I am the user, right? I'm trying to draw myself. Yeah. I go to Instagram. This is my mobile. I upload my picture or take a selfie. I'm taking a selfie here, right? So I took a selfie, nice selfie. I posted it. Now there are my two friends, right? One friend is in US. One friend, okay, maybe they are just two friends. They can be anywhere, right? This friend is in India, right? They always follow my tweets or my posts. So this guy is seeing my new selfie, right? This guy is still seeing is not seeing my selfie, right? That's fine. Not a problem. Maybe after 1 minute, this guy also see my selfie. This is okay in case of Instagram. But if it is my bank account, I'm transferring money, then that could be a problem, right? Because he may be in urgent need of money, and if he is receiving money after some time, or there is inconsistency, then that could be a problem. He's seeing my old balance, that is a problem, right? So yeah, this is about consistency in Instagram. Clear? So you need availability, not consistency here. So you have to share that. This table design and all we covered. Right now, Kafka part, I did not explain here. Let's explain this. You need high performance. There are many users who are posting messages, right? So the news feed could be generated using Kafka. Right? So this is why they are using Kafka, because dynamically it has to be generated, right? So when the users are posting messages, it's publisher subscriber model, classic publisher subscriber. Followers will be looking into the topic. Per user, you will have a topic. Whenever you are posting, you will be posting in your topic. All your followers will take the message and newsfeed will be generated in their feed, right? There could be a microservice which will be generating the feed, right? So you may have various use cases. You will generate post feeds using Kafka. You will generate advertisement placements also using Kafka. And you will get notified on updates. So this is what Kafka is used for. Right. But yes, in Instagram, there is a lot of machine learning part also. Based on your like, and they will customize the new post, what kind of post you should get, friend recommendation, etc. But yes, that will be outside the scope of system design interview. But yes, if you are applying for ML position, you may be asked, give me how you will approach generating requests for how will you suggest friends, or how will you suggest new social connections or posts to users? How will you rank the content? All these things will come into AI ML interviews in case you apply in AI ML. But yes, this is for full stack developers. This is for no non-AI ML. So you will have to just give this design that you will use different kinds of microservices. Basically, this is your microservices. You have follower service, you have user feed service, you will have media hosting service, you will have different kinds of service you can name. You may use different kinds of data storage. For per microservice, you will have a different database data storage, and you will use Kafka to generate feeds. And the other part is which I also have to talk about is CDNs. Use of CDNs are very important here, because if videos and images have to be shared with users, then CDN, your content should be cached in the CDN, right? So you should also make a mention of CDNs. So this one component will be there. It is like a cache, and image URLs, images will be fetched from CDNs. We'll cover details about CDN in the next class. How to cache content for fast delivery to users, we will cover in the next class. Right? Kafka we covered in the last class in detail. So if you have not attended the session, view the recordings. Right? If someone is interested in knowing more about Neo4j, it's not that too complicated to learn. You can, this is the website for learning about Neo4j. Right, so this is Neo4j. Lot of resources are there for learning about Neo4j. You can install and try it out also. You can play around with it, maybe on Docker, on any other, on your machine also, based on, yeah, I haven't tried it out, but yes, you can use, I've used it in cloud. So you can check somehow. Yeah, some sites maybe some problem because of network or monsoon. Yeah, some sites are loading slow, but yeah, these things could be optimized by using CDNs. So if I look into the network developer tools, let's see why I am not able to load this page. Yeah, let's see here. Network. Let me start recording the calls all. And yeah, I think now this is recording network activity. And I clicked on. Where was that? Learn, and then videos. It's loading. Say accept cookies. HTTPF. So yeah, I see some information here probably. Yeah, so they have a lot of articles and learning material here. I think so, but yes, let me reduce this further so that I can show you here. Yeah, this is about Neo4j, but yeah, is it in the videos page? No. Now this is the video page. Right? Yeah. Now when I click on some guy's video, this getting loaded, right? This coming from YouTube. Yeah. So this would be using CDN. All these requests where they're fetching content, they'll be using CDNs, right? So if you analyze here, you will see some CDN requests, because let's see, this is embedded player, right? So this may be coming from YouTube. So not sure about whether CDN would be used here, but yes, if suppose some content is coming directly from some video upload site, let's say, for example, LMS site. And we are viewing the recordings for any of the lectures. So this is today's lecture, so won't be available for you for recording. But yes, if I'm viewing some other recording, which may be 27th of, this content should be coming from CDN for faster performance. But CDNs are expensive, so not sure whether these will be coming from CDN, because yes, this takes money. So yeah, we'll cover in depth about CDNs in the next class, where we will be discussing architecture for Hotstar, Netflix, YouTube, etc. Right, all video streaming and recorded video content delivery platforms. Right, awesome. And you can be ready with your doubts for Instagram or anything related to the previous classes. Great. Have a nice evening.
Thanks, sir. Good night.
Good night.
Thank you.
Sure.